about digital terrain models, we talk about GIS models of the terrain that can be in several different formats. If we have it in a grid or raster format, it's typically referred to as a digital elevation model, or DEM. If it's in a mesh format, this is a triangulated irregular network, or a TIN, T-I-N, and this is one where all the triangles fit together to form the shape of the terrain. And lastly, we can make digital terrain models where we're representing the elevation as lines. And the way that we typically do that is with contour lines, and this of course would be in a vector format. Here's an example of a grid, and in this case each grid is color-coded by its elevation, or how high above sea level it is. So we run from green values through yellow, orangish, and pinkish, and up to whitish values for the highest elevations here. And using this kind of color scheme, we're able to see things well in 3 dimensions. This would be an example of a TIN. Instead of having a regular network of grid cells or points, we just make irregular triangles. And these irregular triangles, typically the smaller ones, are where more rapid changes in elevation occur, and the larger triangles are where less change in elevation occurs. Unlike the DEM, where each grid cell has one elevation value, here the points at the corners of each triangle have elevation values, and then each triangle is sort of tilted in 3 dimensions based on what its 3 corners are. So we could read slope or aspect directly off one of those triangles. The third type of format for elevation models are contour lines. And these contour lines are as if a horizontal plane at a particular elevation is intersecting the topography, as in this example here. So this would be the 0 line of elevation intersecting the topography, where blue turns to green. Where dark green turns to lighter green would be where level B is, which is 50 feet higher than the first level, and where it turns from a darker green to the lightest green, that would be where the 100-foot horizontal plane intersects the topography. And then we just get a series of contour lines. Each one of those contour lines would have a value associated with which plane is intersecting it, or what its elevation is. And then we can use this also as a digital terrain model in order to make different sorts of 3D maps.